The primary suspect identified in the yogurt shop murders case was Robert Eugene Brashers, who was already deceased at the time of the discovery. His connection to the crime was established through YSTR DNA analysis, which linked him to biological evidence found under the fingernails of 13-year-old victim Amy Ayers. The DNA results showed an extremely high probability of a match. Providing strong forensic support, additionally, shell-casting ballistics tied Brashers to the scene, further validating evidence even decades later. This breakthrough was significant because it solved a cold case that remained unsolved for over 30 years. It also cleared previous suspects who had been wrongfully accused. The identification of Robert Eugene Brashers demonstrates how advancements in forensic technology can lead to both justice and exoneration, showing the power and importance of continued development in forensic science. Forensic biology continues to evolve with more advanced DNA technology that allows for higher sensitivity and more precise matching. Modern methods such as improved YSTR testing and expanded DNA databases make it possible to identify suspects even when evidence is limited or decades old. As tools improve, investigators can now analyze degraded samples that would have been unusable in the past. These advancements also bring ethical concerns. There are ongoing debates about privacy and the security of genetic information, especially regarding the use of public genealogy databases to identify suspects. If forensic DNA is misinterpreted or mishandled, there is a risk of wrongful matches or false accusations, which highlights the need for careful oversight and regulation. Preserving biological evidence is extremely important because techniques that may not work today could be effective in the future. Even smaller weak samples can later provide answers as technology advances, allowing cold cases to be revisited and justice to be served. DNA can persist in biological samples long after a person has died because it is a stable molecule housed within cells. In humans, DNA is mostly protected inside the nucleus of cells, and in some cases mitochondria, which shields it from immediate degradation. Even after cells die, DNA can remain intact if the surrounding environment slows down the activity of enzymes and bacteria that normally break it down. Factors that help DNA persist include dry or cold environments, which help slow decay, protected sites on the body, under the fingernail and bones and teeth, encapsulation within cells, which shields DNA from chemical and physical damage. The persistence is what allows forensic scientists to extract DNA from old and degraded samples, sometimes even decades later, to identify victims or suspects.